We're now going to look at continuously compounding interest. Its formula is very simple. A equals P times E to the RT. A is the total amount. P is that same principal or starting amount. R is your interest rate. T is your time. And E actually refers to the exponential function that actually shows up physically as an E on your scientific calculators. So if you have a better estimation for what E is, if you type it into a calculator, you're going to get out the value roughly 2.718. Let me go ahead and show you what I'm talking about. Come over to here. If I want to put in E, looks like this here. E to the first power is 2.718, all that stuff. So I'm not going to actually type in the numbers 2.718. I am simply going to use E. So that button, E to the something, that refers to the exponential function, E. Alrighty. So continuously compounding interest climbs the fastest because the exponential function is constantly recalculating. That's why this interest on interest is happening non-stop. And there's nothing special for this one. It's used in a variety of investments and loans. So let's take a look at several. In example 6, Quark invests $8,333 in a savings account with a fixed annual interest rate of 8%, and it's going to be compounded continuously. What will the account balance be after 12 years? Let's go ahead and break this down. We have the principal. P equals 8333. We know the interest rate, 8%, so 0.08. And we know that the time is 12 years. And because of the phrase compounded continuously, we are going to use E. Okay, so our total amount is P E to the RT. Let's go ahead and plug these things in. 8333 times E raised to the 0.08 times 12. And we plug that whole thing into the calculator, we'll get out the actual amount of money he made or had at the end of his balance after 12 years. So let's come back over to our handy dandy calculator and let's slide this over. 8333 times E raised to the 0.08 times 12. Okay, so that's a total dollar amount. Let's come back over to here. A equals, in dollars, 21,763 and 27 cents. All right, let's go ahead and separate this. So again, he only invested $8,000 about. At a high interest rate of 8%, after 12 years, he made close to $22,000. That's a pretty good return of investment. Let's take a look at another one. In example 7, Zelina invests a sum of money in a retirement account with a fixed annual interest rate of 5.63%, also compounded continuously. After 15 years, that balance reaches $5,912.41. What was the amount of the initial investment? In other words, what was the principal? Let's start with what we know. We know the rate, that 5.63%, 0.0563. We know the time, 15 years, and we know that total amount, that total balance, was 5912.41. Okay, I'm going to go ahead now and plug this into our formula. So again, thinking about A equals P E to the RT. Let's plug in what we know. So we had 5912.41 equals P times E raised to the 0.0563 times 15. Okay? Now to solve for P, I have to get it by itself. I'm currently multiplying P to all the stuff in E. So let's go ahead and divide both sides by that amount. Divide left and right by E, the 0.0563 563 times 15, and the same thing over here. 0.0563, 15. Okay? Notice on the right-hand side, those are entirely gone. These e's are now done. Okay? All we have to do to get that principal is type this into our calculator. And again, that's why I'm saying make sure you know how to access scientific calculators, because that's how we're going to do this. Slide this over here and clear all. So I want to start by typing in a fraction. 5912.41 divided by, and again, I want to use that exponential function, and then its exponent is 0.0563 times 15. Okay? So this is the principal, that starting amount. Let's go ahead and pick a different color here. Let's grab blue. So that principal was, in dollars, $2,540.99. So you invested that amount, and after 15 years, your amount was $5,912. So back up the top, this example set was for continuously compounding A equals P times E to the RT.